So let's look at, first of all, predicting the value of a position in a given pattern. Okay, so let's say we're given a pattern that looks like blue, green, blue, red, yellow, repeating. And we might be asked to find the colour of the 75th position of the pattern, or the 100th position colour, or the 21st position colour, or the colour at any given position. How do we approach a problem like this? Well, the thing to do is to draw a table, to write down position and colour and fill in. We see that it goes from 1, 2, 3, 4, 5 repeating, so we represent that in this column, and we write the associated number beside the associated colour beside each number, and we have our table, and the pattern repeats every 5 blocks. So we immediately go always to the 5th block, and we say if we were to divide our position query by 5, if the remainder is 0, then it's going to be yellow. If we were to divide our position colour query, in this case say 75, if we were to divide that by 5 and the remainder is 1, it's going to be blue. If we divide our colour by 5 and the remainder is 2, it's going to be green. Divide by 5, remainder 3, it's going to be blue. And divide by 5, we get a remainder of 4, it's going to be red. So, for example, if we were to look at our 75th position, we divide that by 5, we see that that's 15 and there's no remainder, so it must be yellow. If someone says to us, well, what's the colour of the 100th position? We divide that by 5 and we get 20, and again, no remainder, so it's yellow again. And then if we were asked for, say, the 21st position, we divide that by 5, but 4 5s are 20, so we have a remainder of 1. 21 minus 20 is 1. So for remainder 1, it's the remainder 1 position we're looking for, and we say that's going to be blue. So let's take a look at the graphs that we met with in this chapter. And if we just remind ourselves that often, the graphs, we start with the story. From the story, we build some sort of equation where we equate one thing to another, like the cost of a taxi ride, equate that to how far we go in the taxi. Using this equation, we build a table of data. That table of data gives us an x and y value which we can plot on a graph. And then once we have the graph, we can read data from the graph, and we call that extrapolating data. Okay? So for example, a taxi charges €4 call out and €2 per kilometre travelled. So we need to, first of all, write down an equation which relates the cost and the distance travelled. And we can see, or should see, that the cost will always be equal to €4, which will be charged for calling the cab company out in the first place, plus €2 per kilometre travelled. Okay, so for every kilometre we travel, it's going to cost us €2 plus the 4 for calling the car company out. So if we build a table of distance in kilometres against cost in euros, then we can see that 1 kilometre travelled will be 4 plus 2 times 1, and it gives us 6. And 2 kilometres travelled will be 4 plus 2 times 2, which will give us 8, and so on. We plug in the values here for distance into here, and we multiply that by 2, add it to 4, and that gives us the corresponding costs. And so once we have this table of data, then we look towards plotting the data on a graph. We take the distance values and we mark them along, or we mark a scale representing kilometres along the x-axis, okay? And then we use the y-axis to represent our cost in euros. We look at our data for distance, and we see that it goes from no distance up to 10, so we would graduate our distance scale up to 10 kilometres here from 0 to 10. And we look at our cost axis, and we see it goes from 6 or from at least nothing up to 24. So we would graduate our y-axis 1 block, say, up to 25 blocks, up to 25 euros. Okay, so it's from 0 to 25 here on the y, and 0 to 10 on the x-axis. Okay, and then we simply plot the data. So we look at a distance of 1 kilometre, and we see that that gives us a point somewhere around there at 6, 2 gives us 8, 3, 10, and so on, and onwards we go, and we plot what turns out to be a straight line. Okay, and if we notice when we plot graphs like this, that the line cuts the y-axis. We can see that it cuts the y-axis at 4. Okay, so apologies, there's a mistake. There's a 6 there. That shouldn't be there. It should be 4. And we should know that it is 4 because it's this 4 in our equation. It's always this constant. That is the value at which the line will cut the y-axis. And we should also note from the straight line graph of when we plot data like this that the cost increases by 2 euros per kilometre. Here is our 2 euro increase there per kilometre. And this 2 euro increase is known as the slope. The slope of this line is 2. In other words, the value of the cost increases by 2 euros for every 1 unit step in distance. So every time we increase the distance by 1 kilometre, the cost will increase by 2. The rate of change of the y-axis to the x is 2. So we can use these graphs then to extrapolate data, as we've mentioned before, where we look to see, well, how much will 11 euros get me? How far can I go for 11 euros? So how we do that is we'd actually go up to the graph up to 11 euros, and we'd draw a line straight across to our straight line graph, drop the line down, and wherever it cut the x-axis, that would be the distance which we would be able to travel for our 11 euros. We can also use the equation itself to see how much would it cost me to go 20 kilometres. We'd simply just put our 20 in here. We'd have 2 times 20 is 40 plus 4 we would be able to go 44. It would cost 44 euros to travel 20 kilometres.